Hello students, how are you? Today we are going to launch a new thing. New thing is an activity session for you. It's a fun session for you where we are going to learn a little bit of physics via some decent activities which I am going to perform live on you, and you can be also doing at your comfort of your home with the very common things which are around you. See, sometimes we feel that the physics is very tough. Sometimes we feel that. And when we start looking around us, we find the similarity in what we study and what is happening around us. The article which is upcoming in our lectures, that is a center of mass article, is one of such a lecture where we use it practically every day in our life. We're actually habitual of it. But sometimes when we have to learn it in a formulation way, like in a text mannerism, we find it a little boring, a little overdue stuff. But now, with the activity session, we are just going to make the study a little lighter, a little lighter. Of course, you will have to study. See, of course, okay, let's kickstart the activity session. Now, I have a pen in my hand. I have a pen in my hand and I've got nothing to do. So what do I do? I've got nothing to do. So what do? I just keep on moving the pen like this. Have you ever noticed and thought about this? That from where you keep on doing this particular activity, where you keep on doing this activity, and if you will see and you will check it, or you will find that we are into our lecture. Already we are into our lecture. Now see, this is a rod. This is a rod. I'm supposed to hold it. I'm supposed to hold it in a stable position. So I'm using my two hands. Not wasting my energy. I'm holding it by two hands. So what did I decided? Let us hold this by a single hand. So I decided to hold it by a single hand. Oh, what has happened? Oh, it started to oscillate. It's not stable right now. What do? So I hold it from here. Oh no, it is not stable. I hold it from here. No, you will say, sir, it's a common sense. Center se pakado. So I hold it from the center. So I hold it from the center and see, by using the single hand, it is supposed to be stable. So it's a common sense. It's a common sense. The common sense is of the center of mass. Can you balance an apple on your finger? Can you balance an apple on your finger? See this. Oh, it's a magical trick. I'm balancing this on my finger. I'm slowly removing my thumb also. See, it's balanced on my single finger. You can also do that. Why it's so possible? Let me explain to you. See, I'm going to explain a lot of things. Before that, I'm going to show you an age-old trick. What is that age-old trick? And an age-old trick is supposed to be to find the center mass of this particular rod. It's a very age-old trick. And the goodness is, sometimes the age-old trick becomes like a question. Like this year in the JEE Advanced, you got a question based upon this basic age-old trick. And what's the trick like? See this. You hold this rod and you want to know the center of mass. So you will be telling, sir, tell me a formula based upon it. Of course, I will tell you the formula later on in the regular lecture. So what is happening? It's an activity. What do? You do like this. You keep on moving your fingers towards the center. It's like a human brain activity where our human brain senses, neurons automatically tend to give us the center of mass. That's the center of mass. Where is the center of mass? Where the entire mass of the system is supposed to be concentrated. That does not look like. So what's the key feature? The key feature is about which the system gets balanced. It's stable about this point. It was done very easily. It's just a very long rod, no? And it's just moving. You can do it at your home automatically. Automatically your fingers are going to meet where? At the center of mass. Where is the center? Sir, of course it is at the center. Oh, is it always going to be at the center? Right now it is uniform. But what if it is not uniform? Not uniform like a diamond ring. It is not uniform, right? Now see this, a broom. Of course, I'm not used to it for this broom, but it's a broom. So what I'm going to do, I'm going to look at the center of mass. Why, sir? We know that it is going to be at the center. Oh, it's not going to be at the center. Let's see that. Let's practice that. Oh, sir, we are doing. And what happens? See where the fingers meet. It meet here, and here lies the center of mass. Where? Here it lies the center of the mass. Now it's not there at the center. Why so? Sir, because there is an uneven distribution of mass. There is an uneven distribution of the mass. So therefore it is not lying over there. Let's see. If I decide to do it little here, oh, it gets so tilted here. What if I decide to do it over here? It gets tilted here. So it is not stable. So where it is stable? Let's find it out once again. So here. About this, it is going to be stable. Neither it is tilting clockwise, neither it is tilting anti-clockwise. That means the overall torque is getting balanced about this particular point. That point is the center of mass. Have you ever enjoyed a seesaw? You know the seesaw? You have seen it in the parks? Have you ever enjoyed it? I hope you would have. Now, see, I'm going to teach you a little more things. See, what is happening? There is an object here, right? This is an object here. And I place it over here like this. Disappointment. ये तो गिर गया. दोबारा रखने की कोशिश करते हैं. वे कोशिश करते हैं. टॉप देखा लट्टू को ऐसे उस पिन पॉइंट पे रखने की कोशिश करो. मुश्किल होती है. बहुत कॉन्सेंट्रेशन के साथ कर पाओगे. भाई लोग तो वो प्लेइंग कार्ड्स के भी वो पूरे शिखर बना देते हैं, है ना? ये तो नहीं हो पा रहा. कोई नहीं आइडिया बदलता है. Bring this box. It's having a slightly more surface, and you place it here. Slightly हो रहा है. But what if you keep it on the longer side? What if I keep it on the longer side? It has a better contact. So better contacts are always there. Better contact should always be there. See, God has given us foot, है ना? Two big foot. I'm a big foot man. My US size of my shoes are pretty large. Okay, I get it with difficulty, right? So my foot is large, so I'm literally more stable. I feel so. See, a larger area of contact is there. See, have you ever gone to a resort? I bet you have gone. Okay, so there would be some adventure trailing over there, a mountain trailing resort. You can see over there. You can see this guy is doing what? This guy is basically balancing himself on this particular rope. Balancing on the rope. Have you done it? I bet you haven't done it. But this guy is balancing on it. This is the center. See this black marker that is supposed to be the center of him. He's trying to balance it. It's very difficult. Reason? Because the area of the contact, my friends, the rope is so thin. When we walk on the road, it is so broad. So we are easily able to balance. But over here, he is not able to balance. So what do? Take the help of a stick. He takes the help of a stick. See, he is holding such a big stick. What's the use of that big stick? See, while he walks, he takes it over here. See, because he is not able to concentrate on the area and on the center. So what is it that he takes the help of this particular rod and tries to balance that center on that particular rope. And because of which, he is able to understand that he is basically walking with his center of gravity exactly falling on the rope. And because of which, slowly and steadily, he is able to overcome that hurdle. Please go and try that, but do get your harnessing correct, okay? And there should be water or something below you. We don't know now what it can happen. See, it's a balancing act. It's basically a balancing act. It's not a magical act. It's a balancing act. See, can you balance this whole tray on this tiny ball? Can you? If you try this one on this, it's very difficult. See this? So it's very difficult. Can you balance this on this? It's still very difficult. Say it falls. Concentration, my friends. It gets balanced. Why so? Because the center of this. Now first thing, where is the center of this? It's at the center. It's at the geometrical center. Reason because it is uniform. And now the center of this, that's the trick basically. The center of it has to be properly arranged on this. And you can do that. Because of it, what is going to happen? The center is going to pass through the center of what? The gravity. The center of gravity. Now you will ask me, sir, is the center of mass and the center of gravity concept exactly the same? I say almost the same. We use it practically the same until we find that the g value, acceleration due to gravity value around us is uniform. In that condition, the center of mass and the center of gravity is going to be located at the same place, right? So you can easily balance it, correct? Easily getting balanced over there. Now, suppose you have a non-uniform body, like this, like what? Like this destroyed hanger, a destroyed hanger. Have you ever thought of that why the hanger is shaped like this? Now, we can easily understand this particular thing. See, suppose you have the hanger like this. It's a very distorted kind of a hanger, and you tell me find the center of mass of this. It's a JEE advanced problem, sir. Find the center of mass of this. I will be looking at a formula here, there. Then I said, yeah, just leave out here. Let me tell it practically. Will you buy it? So the examiner said, okay, let's give it a try. So I gave it a try, and I brought a rod on which I simply hang it like this because it's a hanger, so I have to hang it. So I hang it, and then I said, see examiner, I have located the center of mass. And it is somewhere here. This you can do the calculation and find out. But I am telling you it's definitely here. He asked me, how are you so sure about it? Because then only the gravity is going to pass from this point, and hence it will be passing through this hinge point and it will be stable, sir. It will be stable, sir. He says, are you sure? I said, very sure, sir. I can give you another example. See this, sir. I'm holding this like this. Okay, it's stable? Yes, it is. Now move it like this. Is it stable? No, it comes back here. Why does it come back here? Move it opposite side. It again comes back here. Why it comes back here? Because the mg, which is acting from the center, is passing through this hinge point. It has to. You remember that the center of gravity has to pass through this particular hinge point, below that particular hinge point, such that this remains stable. It's very simple. You can do this by anything. You can do this by this box, also move this. It again comes back here. The reason is again the same. The center of gravity has to fall below this particular point. That's what happens in the case of the hanger. That's what happens in the case of the hanger, where you just hang it and automatically it is going to little bit oscillate, and finally the center is going to fall below this particular point, and that's an activity to learn where does the center of mass basically lies. And now what do you do? You basically try to make it symmetric, the word, the next important word in your life. That is a symmetry. Now, we all love symmetry. We all love symmetry in life. We are also symmetrical. We have 2 ears, right? We have 2 nostrils. We have 2 eyes. We have 2 hands. We have 2 legs. And symmetrical about us. Our rib cage makes us, our body so symmetrical. Our center mass is at a correct position such that we are stable in life. See, this is kind of unstable. So you move it, and move it like this. Now see. I'm not displaying my strength. I'm showing you the symmetric behavior. Now the center mass is going just like below over here now, and you can hang over your clothes symmetrically on both the sides like a shirt, and it will be balanced. So the center mass is a stability idea. So let's understand the stability a little more. Say this is a box, and this is another box over there, right? And now we place a box on box. Like this. Okay. Now what happens? Nothing happens right now. It's so boring. Now we start shifting it here like this. Does it fall? The upper one? No. Does it fall? No. Does it fall? No. Does it fall? No. Does it fall? No. Oh, it falls. Why does it fall? So let's make it a little slow. Now move it. Why it is not falling? Let's understand. So what is happening? The center of this upper box is here. And the edge about which it basically tilts or rotates is here. So the center of gravity or the center of mass is lying to the left of it. So that mg over here is exerting this weight torque, and hence it places in contact. Now as I move it over here, the center of gravity keeps on shifting. It keeps on shifting. There is a critical point. When the mg of the upper box is going to just pass through this point, just pass through this edge. So then if you just slightly move about it, so what will happen if you move it like this? The center is going to shift here. It is going to apply a clockwise torque like this as a torque, and hence it is going to follow. So it becomes unstable. So you have seen the beautiful overhangs on the malls, on your buildings, on your हमारे घर की कोठियों पे बाहर ओवरहैंग लगाते हैं. कैसे लगाते हैं? By generating the concept of the center of mass and the stability feature. There's a lot to learn. See, this is a glass. Have you seen the glasses in life? Of course you have. It's a green glass, so it is not coming. Or now it is coming, right? Now, see, have you seen this glass? So it's a symmetric glass. It's a cylindrical symmetric glass, right? But what about this? It's a conical glass. So where should be the center of mass? On the heavier side? No, just imagine you have a sun and earth system. So where is the center of mass? Now we had a broom. With us. This was a broom with us. Now where is the center of mass of it? The center of mass is supposed to be here. Where? It's closer to the heavier one. Since it is closer to the heavier one, so keep on thinking. Where is the center of mass of the earth and the sun system? Of course, it's closer to the sun. In the case of the earth and the moon system, it will be closer to what? The earth. In a similar mannerism, when you have this particular glass, it's a non-uniform. So where is the center of mass of it? It has to be where the more mass is there. So you might be thinking, sir, here is a more mass. But in that case, it is going to become unstable. Why? Because the center of gravity will rise. And it is going to become unstable. There will be more toppling torque which can act on it. It can turn over quite easily. This one If it is kept like this, it has more tendency to topple, see? But if you keep it like this, it has a less tendency to fall over because the center of gravity is lower. If you keep it like this, the center is higher, so it has more tendency to fall over, and therefore the center of gravity must be as low as possible. So for this, the center of gravity is supposed to be higher because the more mass is looking here at the first part, upper part. So therefore the glasses are made thick at the bottom. See this? This is thick at the bottom. You see any glass in your household, you will find it thick at the bottom. Why so? Such that the system becomes more stable. You have seen the Formula 1 cars. Have you seen the Formula 1 cars? They have the low chassis. They have the low height. Just not like our SUVs. Just not like our SUVs. SUVs have the high center mass height. But the Formula 1 racing cars have the low chassis height. For what? For keeping the stability. The center mass also explains to you the stability feature in much finer detail, also related to the concept of the potential energy. For example, if someone told me, I'm gifting you books. So he gave me book. This one, then this one, then this one, then this one. I was saying what to do with these books. So he said arrange it. Okay, sir, I said arrange it. So I started arranging it like this. I arranged it like this. He said, you fool, you don't know how to arrange. I said, why so? He says, arrange it in a stable manner. I said, what's the fun point? Why do arrange in a stable manner? He said, because when you arrange it in a stable manner, it will not be compressed in the correct mannerism. What to do? Keep the heavier one below. So this is the most heavier one. Like this, like this, like this. And now what is happening? Oh, it's perfect. Why it's perfect now? Because the center of gravity is as lowered as it can be, and therefore it becomes stable. So think upon that wire top, a wire top, or a conical part, a conical section can be balanced about a broader base. The center of mass is lower, and if you revert it, oh, it is not balanced because the center of mass becomes higher. So we are understanding a lot of things. Let me show you another thing. It is a very common experiment. Is with a cutlery. You're getting bored in a restaurant and in a Chinese restaurant. Of course, so you will be using the fork then. Okay, so then we need to balance it. So see this, I'm going to balance it. Just this, sorry, it's so easy. Okay, so I'm bringing a knife also. And I'm going to balance it. Like this. It's getting balanced. So it's also simple. Okay. I'm bringing a glass also. I'm full in the mood of a full course dinner. Okay. So I'm bringing it over here and trying to balance here and trying to balance and it's balanced. So it's दिख नहीं रहा. Wait. See the balance? Yes, sir, it's balanced. Are you able to see? Now, how do I? I have to locate the center mass of the system and keep it at the edge of this glass. The center mass of this to at the edge of this. Just at the edge of it. If I am able to do so. And it gets balanced. If I just move a little bit like that, oh, it falls. So that's how critical the stability is supposed to be. I'm going to show you a very common thing which you will find in your household to understand this concept more. See, have you got a tripod? Do you know why it is known as a tripod? Sir, what are you telling? It's a tripod because it has got 3 legs. What if I don't have one leg on it? What if it got broken? And then I decided to keep it over here. Oh, it's gone. It's not there. And then I found, oh, my bad. I actually did not open this. So it got opened. And now what happens? I place it here and it's stable, my friends. It's stable. And now you will get a still picture from it if you capture it. The reason because the center is passing through the center, the geometrical center. So for the uniform bodies, the center of mass usually lies at the geometric center. Where does it lie? At the geometric center. For others which are not uniform, then comes the word weight. Weight means, I say the center of mass is supposed to be an average. Average means like this, that supposedly you are having this rod. And there are masses here, with this average of it at the center. So I say this is the center of mass. But then, my dear, I say it's not the average. is not average position. So what is it? I said it's a weighted average. Why so? See this broom once again. Now, if I look at the center mass once again, now you will be understanding that this is just not a balancing act. It's a natural process which you can do again and again. Now, where is the center mass over here? Is it just an average? If it was average, it's a weighted average. Why is the center mass here? Because it's lying closer to the heavier mass, because the heavier mass has more weightage. That's the reason it's lying closer to the heavier mass, and that's why the center mass is known as the weighted average of the various masses of the system. Now, if you go on a seesaw with your friend who is not exactly identical as you, so what you're gonna do? You're gonna go and sit at the same ends. He's also sitting at a far end. You also sitting at a far end. No, you should not do that. So what you should do? You should do the heavier one of you should be sitting closer to the fulcrum, that is the center, and the lighter one of you should be at a farther end. So this is how you're gonna be stable about that particular seesaw. Now see this one. You can also watch various kind of such events in the picture-in-picture diagram. See what this animation currently is showing. Suppose I throw this from the center mass, it goes straight up. It does not tilt up. If I throw it from the center, but if I throw it from anywhere else, it is going to tilt. Because it is going to generate some movement about the center. Because if I push it from anywhere over here. So these are some of the activities which are very much interesting. See the picture-in-picture. Here is an eagle. It's an eagle. It's getting balanced at the beak. So what do you make of it? That the center mass of it lies over there. The fidget spinner which you spin, that is balanced about the center. And there are so many things. This is a natural rock behavior. You can find the temples which are made up of just rocks without the cement, where the rocks are just placed in a staggered mannerism, just balancing the center. Then little bit here, then little bit here, then little bit here, then little bit here. This is at the center lies over there, and because of which it becomes stable. You can find on the Google such many marvelous monuments which are based upon this particular idea. You would have seen very good monuments carved out in the Himalayas also. Himalaya is stable because of the structure. But the structure, see this bird is getting oscillating about the center of mass point. The center of mass is hinged over there, so it keeps on oscillating. The boxing joker and this parrot, see this parrot. She's trying to balance on this ball. She's just trying to balance. She's not able to, because she's not able to concentrate the center over there. The boxing joker, you hit it on the nose. What happens? It comes back. Why so? You hit another person, he'll fall off. He will fall off. Why? Because the center of mass is higher. But what happens in the case of the boxing joker? The center of mass is so lower. See that boxing joker. The center of mass is so lower over there. And what happens if you hit it? It will again come back. Hit me again. How many of you like that to hit you again? And therefore your center of mass is higher. So these were some of the activities. I can keep on making more such activities in the near lectures also. This was a fun activity which you can try at your home. And with this, a little knowledge of the center of mass, with a little knowledge of the definition also, we will be leveraging our article tomorrow and begin with the idea of the text theory of the center of mass. Thanks for spending your time with me. Have a nice day.